Everyone, my name is Yazan, and today I will talk about technology and software in competition neuroscience. And my friend is Rakan Ahmed Berk. So let's begin. In the beginning, I will talk about some interesting fact about the brain. So the brain contains 86 billion neurons linked together by 100 trillion, and the entire brain system in just 20 watts of energy, less than the energy needed for the small light bulb. So this is a very introduction to the complexity of the human brain. Now let us talk about an interesting story. In the past, especially in 1952, a scientist, Hodgkin and Huxley, did the very first simulation of seamless wide neuron. They were solving the mathematical equation manually using hand count mechanical calculator, and took them 3 full weeks just to simulate a single spike. But today, with advanced software and modern computer, we have the ability to simulate thousands of very high logical fidelity, just milliseconds. So what has changed? First, high performance language like Python, and there's C++, and some other language we will talk about. The second thing is simulation engine and smart distribution where the CPU organize the workflow, RGB, and the massive conventional work. The third thing that changes the delay framework that help us detect pattern, predict sales activity, and compare them with real world data. Final one is data standard to know. It is for science to share and research without any nightmare of cleaning up the data manually. Now let's look at the main language we use today with the neuroscience application. This one is the most popular one. It is Python language because it is very style and has a great tool for data. Second is C++. This is ultra fast and runs the simulation with you. Third one called Julia. So this is smart language because it is like Python and C++ with the speed of C++. Now let's talk about the simulation tools. So how we actually do this? We have two tools. If you want to zoom in and see how one single cell makes the city, you use Neo. It is like microscope, but if you want the big picture to see more cells talking together, you switch to Nest. In short, one for the pixel, one for the object. Third engine, we'll talk about called Brain 2. here we can write the code using the mathematical equation library and automatically convert the code into C++ via this. So now I'll talk about short experiments I conduct using the print. So it is go like this. How does the brain generate electric signals? So we built a digital neuron using Python and brain tools to simulate real brain spike program. This model using three simple rules. First one is charging energy start from zero and reduce over time. The second rule is reset elements. It is 0.8. Most energy decide as a second. After that, start notifying the energy drop back to zero, as you can see in the graph. So as you can see in the graph, also the blue line represents the charging. The red one is the limit that we set, and the third one is I mean, setting is syndrome after the limit, as you can see. And additionally, the number 16 in the bottom is that it's represent 60 milliseconds. The neuron graphic tile. First, bottom left. Conventional address targeting simulate brain scale circuit at vertical realistic speed. The breakthrough was Intel is allowing to ship 100 fascination for smoke and tones, mimicking the brain is even time that she checked. The hypothesis morphic hardware may be the key to unlocking the brain is full complete functional, meaning complexity, the battle variable dexterity, more than history and so it is workflow to the track commences every parameter based on result checkpoint activity. Modern DB public repository for sharing computational modern increasing scientific impact and credibility is practice organized code data and meta data to withstand security and enable independent verification. The future of frame rotation Gene 18 is graph-based natural activity. 3D abstract complexity spike data into readable conceivable representation. AI and neuromorphic hardware together where they also big data and essential in real time at like efficiency. Go to action, adoptable systems to machine and turn the brain. Thank you for listening.